Hello students, welcome to mathematics class. See, last class we discussed the examples based on implicit and explicit functions and differentiation by the method of substitution method. Now, next we'll take logarithmic differentiation. Before starting the logarithmic differentiation, let me know the definition of logarithm. See, as already you know, the logarithm tables and calculations, everything in physics lab, I hope. See, in earlier days, the calculation of multiplication, division, a long number, it is very difficult to find. In that case, John Napier, the scientist who introduced logarithm. Okay, first we define the definition of logarithm. See, if a is a positive real number other than 1, okay, what is the condition? A is a positive real number other than 1, nothing but a must should be greater than 1, correct? A is a positive real number other than 1 such that what it represents? A to the power x equal to m. Correct? A to the power x equal to m. Then x means power. This power. Then x is called the logarithm of m to the base a. Did you understand? The power, this x is called logarithm of m to the base a. And we write, see, x is equal to log of m to the base a. Log of m to the base a. Condition, a should be positive number and a not equal to 1. Okay, means this definition we express it in the form of symbolic representation, that is, if a to the power x equal to m, did you understand? A to the power x equal to m is the given number, then it can be represented in the form of logarithm is x is equal to the power, x is equal to log m to the base a. Or suppose if I take reverse form, that is x is equal to log m to the base a. Suppose we take given in terms of logarithmic form, x is equal to log m to the base a, and that can be written in the form of exponential form. That is, see, this is anyhow you know that it is power or index, and that is a power or index of what? A. Therefore, this base will goes to right hand side, and that is a to the power x equal to m. Okay. By knowing this definition, we will take some examples based on that. For example, I will take 10 to the power, just concentrate, 10 to the power 2. Already we know that 10 to the power 2 is what? 100. Correct? 10 to the power 2 is 100. Apply using the definition. This is exactly in the form of a to the power x equal to m. But our definition says what? The x, the index or the power, x is nothing but logarithm value, that is log of m to the base a. Means, what is our x here? 2. 2 is equal to log 100 to the base 10. Log 100 to the base 10. In this way, we can write the example. Okay. Next, we will take another example. Ten to the power 3. We know that 10 to the power 3 is what? 1000. Correct? Means it is exactly in the form of given a to the power x is equal to m. Okay, and we know that x value, this is we can write x is equal to log m to the base a. Means our x is what here? 3 log of 1000 to the base 10. Did you understand? Okay. Next, another one example. A to the power 0 equal to 1. Okay. A to the power 0 equal to 1. Means it is exactly in the form of a to the power x is equal to m. But what is your definition? X is log of m to the base a. What is your x? X is 0 and it is log what? 1 to the base a. Okay? Log 1 to the base a. Nothing but a to the power 0 equal to 1. That's why they have mentioned what? We are not taking the value of a is 1. Next, we will take 10 to the power 0. We know that anything raised to 0 is 1. Therefore, by definition, 0 is log 1 to the base 10. Next, we will take 100 to the power 0 is 1. Means we can write 0 is equal to log 1 to the base 100. Please remember that. Please remember that if log 1 to the base a, log 1 to the base 10, log 1 to the base 100. If log 1 is exist, always its value should be 0. Remember that. Suppose if I take log 1 to the base 1000, remember that its value is 0. Okay. Remember that. Log 1 value is always 0. Okay. What we have done here? Log 1 to the base 10 is 0. Log 1 to the base e 0. Correct? Next, log 10 to the base 10. Let me verify. Log 10 to the base 10. We get it is 1. Verify. Is it okay or not? See what the definition says. It is 10. We get it is 10 to the power 1. According to definition, because this is in the form of log m to the base a is x. But it exists if and only if it is what? M is equal to a to the power x. Correct? What is your m? 10. A 10. X 1. Therefore, remember that log 10 to the base 10 is 1. If these two are similar, always you will get 1. And remember that if base, this is base 10. Correct? Base 10. The logarithm to the base 10 is called common logarithm. We call it as, this is common logarithm. Next, the logarithm to the base e. We call it as Napier logarithm. The name of scientist who introduced. We call it as Napier logarithm, or else we call it as another name, natural logarithm. Okay. This is how we can define the definition of logarithm. Please remember. Okay. This is not there in your syllabus, but before starting the logarithmic differentiation, we have to study what represent log. Okay, I hope understand everyone this concept. Next, I will take the sum theorems on logarithms. theorems on logarithms. First one given log mn to the base a means log mn to the base a means it is product. Correct? M into n is nothing but product. Log mn to the base a is given. We have to prove log m to the base a plus log m to the base a. Log m to the base a, log m to the base a. This is we have to prove. See, we have the definition. Just remember, we have the definition. If a to the power x is equal to m, then x, the power or the index x is nothing but the value of log, and it can be represented x is log of m to the base a. This is, we know that already. This is the definition. Correct? And condition is a should be more than, a is a positive real number other than 1. Okay? And next, see, we want to prove this one. The product, this product can be converted in terms of addition. Okay? See, for that I will use the definition of logarithm. Consider log, this is our consideration, mn to the base a is x. Log mn to the base a is x. Next, log m to the base a is 1. Log n to the base a is 7. This is our consideration. Okay. Next, by definition of logarithm, just concentrate. By definition of logarithm, see, x is equal to log m to the base a. X is equal to log m to the base a. By definition of logarithm, we can write it is a to the power x is equal to m. Therefore, we can write this one as mn. Mn is equal to a to the power x. Next, by definition, it is m equal to a to the power 1, and this is n equal to a to the power set. Correct? Means we know that in the form of exponential, m value is a to the power 1, n value is a to the power set. That two values we can substitute here. We get a to the power 1, a to the power set is a to the power x. And according to theory of indices, we know that a to the power y into a to the power z, if base is same, we can write y plus z is a to the power x. If base is same, we can write, see, y plus z is x. Correct? Y plus z is x. Next, see, rewrite x is equal to y plus z. Then, see, what is x represent? X represent log of m of n to the base a. Y represent what? Log of m to the base a. Z represent log n to the base a. We proved this one by using the definition of logarithm. Okay? By using the definition of logarithm, we proved log of mn to the base a is log m to the base a, log n to the base a. Okay? Means, remember that if the product of two function is mentioned in logarithm, that product can be converted in terms of what it is? Addition. For example, if I take log of 30 into 55 to the base a, then we can write it is log 30 to the base a, log 55 to the base a. Okay, did you understand? For example, if I take log of 30 plus 55 to the base a, means we can't write this one as log 30 to the base a, log 55 to the base a. Remember that product can be converted addition but addition cannot be converted in terms of directly. Okay, this is the how we can do the theorem. Okay, the log of 30 plus 55, if you want you can check it. In logarithm table, log of 30 plus 55 value does not equal to log 30 to the base a, log 55 to the base a. Product can be converted in terms of addition. Okay, I hope understand this one. We will take next. This is just a basic concepts of logarithm. Okay, second. Log of m by n to the base a. Log of m by n. Previously we have done multiplication, now it is division. We can write this one as log of m to the base a minus log of n to the base a. Log of m to the base a minus log of n to the base a. Okay. As usual, similar procedure. How? See, we have the formula. What? If x is equal to log m to the base a, then we can represent it is in the form of e to the power x equal to m by definition of logarithm. Therefore, we can write this one as consider log of m by n to the base a. We can consider as x. Then we can write this one as m by n is equal to, by definition, a to the power x. By definition, just go through the definition. Next, log m to the base a, we can take y, then by definition it is a to the power y. Next, log n to the base a, we can consider z, then by definition it is n is equal to a to the power z. By using the definition of logarithm. Okay, next, see, we know that m by n is a to the power x. Okay, or rewrite this. A to the power x is m by a to the power x. What is our m represent in terms of exponential form? A to the power 1. And n represent a to the power 7. And by exponential form, if base are same, and we can write this one as a to the power y into a to the power minus z. Already we know that. And we can write this one as a to the power x is equal to, base is same, y minus z. If base is same, we can write it is x is equal to 1 minus z. Correct. Once we know the, see what x represent. See, x represent log of m by n to the base a. Y represent log of m to the base a. And z represent log of n to the base a. Correct? Means here what we have done? Division. Correct? Division we converted in terms of subtraction. Did you understand? Division we converted in terms of subtraction. Remember that. See, log of 55 by 30, suppose it is given, and this can be represented log of 55 to the base a minus log 30 to the base a. But we can't take, remember that, we can't take log of 55 minus 30 to the base a can be written as log of 55 to the base a minus log of 30 to the base a. Please remember that. Okay. See what we have done? In logarithm, multiplication we have done addition, and division we have done subtraction. Remember these two form. We'll take next class another two form. Okay. Thank you.